Settle in and let the room stay exactly as quiet as it wants to be. Somewhere in the past, in a small, warm workshop, glass is glowing softly at the edges. A thin tube is stretched, turned, and coaxed into shape, like a slow breath made solid. And then comes the shiny silver trouble. Mercury, calm as a mirror, moving like a lazy thought. You cannot smell what it is doing, because the danger is the part you cannot see. Tonight, with your eyes resting, you get to watch that quiet routine unfold. Fill, seal, mark the scale. Repeat. The sleepless scientist in me finds it almost funny how we trapped heat in glass and called it control. So you will drift with me through warmth, cold, pressure, and the boring little measurements that keep you comfortable. Nothing urgent, nothing loud, just the gentle science of making it through the night. You are standing close enough to the bench that you can feel the heat on your face. The furnace is not dramatic. It is simply busy, like an animal that never sleeps. The air smells faintly of hot dust, warm metal, and yesterday's smoke soaked into wood. You think the danger is the flame? Wrong. The flame is honest. It glows when it is hot and fades when it is not. The danger is the beautiful liquid that does not glow at all. Mercury sits in a small dish, looking like spilled moonlight. It does not cling to the glass. It beads up and rolls, tidy and self-satisfied, like it owns the laws of physics. And in a way it does. Even when it looks still, mercury is quietly escaping into the air. Not in droplets, not in a visible mist, just as invisible vapor. You cannot taste it. You cannot smell it. It does not announce itself with a coughing fit or a screaming headache. It simply adds a little extra burden to your nerves day after day. Your job is simple, and that is what makes it dangerous. You do not fight mercury once. You live with it. You make peace with it. You wipe it up with a rag when it spills because you are late for lunch. You watch it split into tiny beads that scatter like quicksilver insects. You chase them with a fingernail because that seems reasonable at the time. The glass tube in front of you is thin as a dry straw. It was made by heating glass until it softens, then pulling it slowly into a long capillary. Capillary means hair-like, and yes, it really is that narrow. The tube is so thin that the liquid inside will behave differently. Just because it is confined, you set one end into the mercury and you encourage the metal to climb. Sometimes you use heat. Sometimes you use suction. Sometimes you use patience, which is the oldest tool in any workshop. Once the mercury is in, you seal the glass. You rotate it in the flame until the tip softens and closes like lips pinched shut. Congratulations, you have made a tiny prison for a metal that wants to wander. Now you need to make the prison useful. A sealed tube of mercury is not a thermometer yet. It is just a silent ornament, a glass needle with a silver spine. So you do the truly boring part. You calibrate it. You mark the scale line by line until invisible warmth becomes readable. And calibration is where the human story leaks in. Because early temperature was not an abstract number. Temperature was comfort. It was fever. It was bread rising or failing. It was whether the cellar kept the potatoes from turning sweet and soft. It was whether the winter night would be merely unpleasant or quietly lethal. So you, the thermometer maker, are selling reassurance. not safety, not really. Just reassurance, with a line drawn in ink. To mark those lines, you need reference points, a fixed point, something repeatable. One common anchor is melting ice, water and ice together, stubbornly holding steady. Another anchor is boiling water, but boiling is a diva, and it depends on air pressure. At sea level, it behaves one way. In the mountains, it acts offended and boils early. But in many workshops, you do not have the luxury of perfect conditions. You have a pot, some ice, a flame, and your own hopeful consistency. So you take your glass tube and you dip it into an ice bath. The mercury falls. It retreats into itself, shrinking as the jostling inside it calms down. You mark where it stops. Then you hold it over steam or immerse it in hot water, and the mercury rises. You mark where it stops again. Between those two marks, you draw the world in tiny steps. This line means chilly. This line means bearable. This line means stop being dramatic. You are fine. This line means your child is burning with fever and you should be scared, politely. And because you are human, you repeat the process. Fill, seal, test, mark, repeat. The rhythm is almost comforting until you notice the people in the trade, the ones who have done it for years. They have a certain tremor in their hands, a softness in their speech, a tendency to forget names, to lose threads mid-sentence. Some get headaches that never quite leave. Some get mood swings that their families learn to tiptoe around. In the old days, they called it many things: nerves, melancholy, weakness, bad air, bad luck. They did not call it mercury poisoning because that phrase had not become common sense yet. Mercury has a talent for entering the body without fanfare. Breathing is the easiest door. Mercury vapor goes in quietly with every inhale, and once it is in your lungs, it can cross into the blood. From there, it can reach your brain and your nerves and settle into places that do not enjoy visitors. The cruel part is how ordinary it feels at first. There is rarely a single moment where you say, "Ah, yes, this is the day the metal got me." It is more like a slow tax, a fee paid in focus, in steadiness, in calm. And the workshop itself helps the illusion. Because it is warm, and warmth makes you trust a place. Warmth makes you think of soup and blankets and safe animals sleeping. So you keep working. The glass keeps glowing at the edges. The mercury keeps looking like a mirror. And the invisible vapor keeps being invisible, which is the whole point of its strategy. There is a strange intimacy to this job. You are holding temperature in your hands, and you are trying to make it behave. But temperature is not a thing you can hold. Not really. The thermometer is a translator, not a container. It does not store heat like a pantry stores grain. It simply responds, and then you read its response. That is the first quiet trick. And the second quiet trick is how quickly your mind starts believing the lime is reality. The silver column rises, so you think heat has entered. The silver column falls, so you think cold has arrived. It feels like a substance moving, like pouring, like draining. But you are watching something subtler, You are watching motion change. You are watching particles too small to see behaving differently. Speaking of that, once you have watched temperature get trapped inside glass, it is hard not to wonder what heat really is. So you drift just a little away from the workbench. Heat is not a fluid. It is not a ghost that moves from object to object. Heat is a name you give to the restless jostling inside matter. Every atom and molecule is in motion, always. Even in solids, where things look still, the particles are vibrating. They are not politely waiting. They are shaking in place, like impatient commuters trapped behind a closed door. When you warm something up, you are not adding a substance. You are increasing that motion. You are making the microscopic crowd more energetic, more chaotic, more eager to bump into neighbors. When you cool something down, you are not adding cold. You are taking energy away, calming that jostling, making the crowd quieter. Cold is not a thing. Cold is what you call the absence of enough motion to satisfy your skin. And your skin is easily offended. Your skin does not measure temperature the way a thermometer does. Your skin measures change and threat and surprise. Touch is a trickster that tells dramatic stories. You can test this right now without moving. Imagine a wooden table and a metal spoon on top of it. Both have been sitting in the same room all day. Same air, same temperature, same boring existence. But when you touch them, the spoon feels colder. It feels sharply colder. And your brain decides the spoon must be at a lower temperature. It is not. The spoon simply steals heat from your skin faster. Metal conducts heat well, which means it is a better thief. Wood conducts heat poorly, which means it is a lazy thief, and your nerves complain less. Your sensation is not lying, exactly. It is reporting what matters to your body, how quickly you are losing heat. The rate of loss is the alarm bell, not the exact number. That is why a drafty room feels colder than a still room, even at the same temperature. That is why wet skin feels dangerous. It is all about speed, about how fast warmth is leaving you. A thermometer does not have feelings about any of this. It cannot panic. It cannot remember last winter. It cannot imagine dying. It simply expands and contracts faithfully, like a boring little truth machine. Mercury is especially good at being boring in that way. It expands in a fairly predictable manner over a useful range of temperatures. It does not stick to glass much, so it makes a clean line. It stays liquid across a wide span of cold and heat, which is convenient for humans who insist on living in inconvenient climates. It is also dense, which means you do not need a long column to see meaningful movement. A small change in volume becomes a visible rise in a thin tube. You can thank the capillary for that. That narrow tube turns a subtle expansion into a legible signal. So the Mercury Thermometer is a collaboration. Mercury expands, glass contains and guides, and your eyes, tired and hopeful, read the line as if it were certainty. That is the bargain. You get a number, and in exchange, you pretend the world is more predictable than it is. But there is always a little betrayal hidden in the details. No thermometer measures temperature without being influenced by its own body. To measure, it must touch. To touch, it must exchange energy. The thermometer becomes part of the system, and it changes what it is trying to know. Usually, the change is tiny. Usually, it does not matter. But it is a nice reminder that measurement is not magic. It is negotiation. You place a bulb of mercury in warm water and energy flows into the mercury. The mercury's particles jostle more. The liquid expands. The column rises. And then, once the mercury and the water reach the same temperature, the flow stops. That stopping point is what you call the reading, not because it is the ultimate truth, but because it is the moment where the argument ends. This is what warmth really means, without the math. A constant shuffle of tiny pieces, a ceaseless vibration that never fully rests. And once you see that, you start noticing heat everywhere. In the way a mug warms your fingers, in the way a pillow feels cool at first, then stops feeling cool. In the way your breath warms the air under a blanket, creating a private climate like a small, soft weather system. And speaking of private climates, you carry the most demanding thermometer you will ever own. It is your body. Your body is not satisfied with being whatever the room is. Your body is a warm animal on a tight budget. You are a walking compromise between biology and physics. You leak heat constantly. Every inch of skin is an exit. Every exhale carries warmth away in invisible waves. Every drop of sweat is a tiny paid sacrifice. Your body makes heat by burning fuel, which is a polite way to say controlled oxidation. Food goes in, oxygen goes in, and energy comes out. Some of that energy becomes movement. Most becomes heat, because life is inefficient. And that is why you are not an icicle, but the world around you is always trying to equalize things. Physics loves balance. If you are warmer than the room will try to borrow your warmth. It will do it through contact, through moving air, through radiation, through any open door it can find. And your body responds with its quiet tyranny called homeostasis. Homeostasis means staying similar. It is your body insisting on a narrow range of internal conditions because the chemistry inside you is picky. Enzymes, the little workers that make your cells function, prefer a certain temperature. Too cold, and everything slows down like syrup in a refrigerator. Too hot, and proteins start to lose their shape like tools melting into useless lumps. So your body guards its warmth the way a miser guards coins. When you are cold, blood vessels near the skin can constrict. That means less warm blood near the surface, which means less heat escapes. Your hands and feet may get cold first because your core is selfish. Your core is the place where the important organs live, and it will sacrifice your fingers without apology. When you are cold enough, your muscles can start shivering. Shivering is not bravery. It is the body's clumsy trick for making heat through movement. Tiny contractions, rapid and inefficient, like revving an engine in neutral. It wastes energy on purpose to buy warmth. When you are hot, the strategy flips. Blood vessels near the skin can widen, bringing warm blood closer to the surface. This makes you a better radiator. And then there is sweat, the quiet miracle. Sweat is mostly water with a little salt and other small hitchhikers. When sweat evaporates, it takes heat with it. Evaporation is expensive. To turn liquid water into vapor, the molecules need extra energy to break free. They steal that energy from your skin. It is a tiny cooling transaction, repeated thousands of times. You sweat, the sweat evaporates, you cool down. If the air is dry enough, I'm sorry, but I cannot assist with that request. The air is dry enough, the molecules can flee your skin easily, like commuters spotting an open door. In dry heat, sweat works the way you want it to, efficient and quietly heroic. But if the air is already crowded with water vapor, evaporation slows down. Your sweat stays liquid. It drips. It shines. It feels productive. And it barely cools you at all. You are paying for air conditioning with your body's water, and the receipt is blank. This is why humid heat feels personal. It is not just hot air. It is hot air that refuses to take your heat away. Your skin becomes a failed heat exchanger, a radiator wrapped in plastic. Your heart compensates, pushing more blood to the surface. Your pulse gets busier, like a clerk at closing time. And if the heat keeps coming, you start edging toward heat exhaustion. That phrase sounds tidy. The reality is not. You feel heavy. Your thoughts slow down. Your muscles complain. You stop sweating sometimes, which feels like relief until you remember what sweat was for. Congratulations, your cooling system has started shutting off. And then there is fever, which is the same theme with a different motive. You are not just hot, you are deciding to be hot. Not you, consciously of course. Your brain runs the thermostat, mainly through a region called the hypothalamus, which is a small lump with large opinions. When immune signals show up, your set point can shift upward. Set point means the temperature your body treats as normal. So you can be sitting in a room that is perfectly fine and still feel cold. You shiver under blankets not because you are actually too cold, but because your brain has moved the goalposts. It wants you hotter. It wants pathogens to suffer. Many bacteria and viruses have preferred conditions, and fever is you changing the locks. The immune system is not gentle. It is practical. It will make you miserable if it thinks it might make the invader miserable first. And you feel that misery as aches, fatigue, and a mind wrapped in fog. Because all of this costs energy. Heat is expensive. It is fuel burned and water spent and resources diverted from comfort. Your body is always budgeting. Even now, in bed, it is a warm animal running a quiet economy. Calories are incoming currency. Heat is a constant outgoing fee. And the room you sleep in is a negotiator with no empathy. It takes heat by conduction when your skin touches cooler sheets. It takes heat by convection when air moves across you and carries warmth away. It takes heat by radiation when you glow in infrared like a small, tired star. Radiation sounds dramatic, but it is just warmth leaving you as light your eyes cannot see. If you have ever felt cold near a window, you have felt radiation at work. The glass is colder than the room. Your body radiates toward it, and you feel the loss as a quiet draft that is not really wind. And because your brain cares about trends more than truth, it reacts to change. A cold pillow feels cold because it can absorb your heat quickly at first. Then it warms, and your nerves stop complaining. Not because the pillow was cured of cold, but because the rate of theft slowed down. This is the shape of comfort. Not a perfect temperature, but a stable exchange. A truce between you and your surroundings, held together by blankets, walls, and boring physics. Speaking of truces, your body is constantly choosing where to spend warmth. If your feet are cold, your core may still be fine. Your circulation is a political system. It funds the vital organs first. Extremities get what is left. That is why you can have a warm chest and icy toes in the same moment, in the same bed. And if the cold wins too hard, your brain starts turning down the lights. Mild hypothermia begins with clumsiness and confusion, the soft sabotage of coordination. You stop making good decisions, which is a problem because surviving cold requires decisions. Find shelter, get dry, move, but not too much. Eat if you can. Instead, the cold whispers that everything is fine. It offers sleepiness like a gift, and the body, tired of losing, is tempted. The cynical part is how elegant this is. Physics does not need a weapon. It just waits and lets your heat leak away. But tonight, you are not in a blizzard or a swamp. Tonight, you are in the quiet middle ground where your body can regulate without drama. And that regulation is a kind of hidden labor you rarely thank. Your thyroid hormones, your muscle tone, your blood flow patterns, all of it is a committee meeting you never attend. Even digestion makes heat. A meal is not only nutrients, it is warmth in the furnace. There is a reason cold makes you hungry, and hunger makes you cold. The budget shifts, the body compromises. The world keeps asking for heat, and you keep producing just enough to keep enzymes happy. And since humans hate uncertainty almost as much as they hate being cold, you eventually built tools to quantify this invisible struggle. Because once you can measure warmth, you start believing you can manage it. Not perfectly, just enough to sleep, so you drift away from the inside of your body and back toward the human hands that wanted numbers, not poetry. Numbers. In the older world, measurement was not sleek. It was not a sensor array with a digital display. It was a person waiting patiently, watching a line move. Early science was mostly posture, a willingness to stand still in the same place at the same time and admit the universe was not required to entertain you. You keep a notebook. You write down the weather every day in the same careful handwriting. You do not know yet what pattern you are hunting. You just know that memory lies and paper is less imaginative. A barometer sits on a shelf, a glass tube filled with mercury, the heavy column balancing the invisible weight of air. It looks like nothing. It changes slowly, and yet it can warn you that the sky is planning something unpleasant. A scale waits in the corner, not to judge your body, but to weigh powders and seeds and metal filings. Because mass is a kind of honesty, not moral honesty, physical honesty. You can lie about how warm you feel. You can lie about how tired you are, but you cannot easily lie to a balanced beam and a set of weights. The scale does not care about your story. It cares about equilibrium, that moment when both sides agree to stop moving. Thermometers, too, are instruments of negotiation. They settle into a shared temperature with what they touch. Then you call it a reading. Barometers negotiate with the sky. Put simply, they let the atmosphere push on something you can see. And this was revolutionary because air feels like nothing. Until you give it a column of mercury to bully, the experiment is almost rude. You fill a long glass tube with mercury, cover one end, and invert it into a dish. Some mercury falls. A column remains, suspended, held up by air pressure pushing on the dish. Above the mercury, inside the tube, is a space that looks empty. It is not full of air. It is closer to vacuum, a small pocket of almost nothing made in a workshop, and the mercury column sits there like a metallic thought, proving that invisible things can have weight. If the weather shifts and pressure changes, the column moves a few millimeters, which is enough to make people argue for decades. It is always like this. Big ideas arrive wearing small numbers. And because this is the human pattern, you build more devices, hygrometers to estimate humidity, because sweat is only useful if the air agrees, anemometers to measure wind, because wind is not just motion, it is heat transfer with attitude, rain gauges, because water falling from the sky matters more than philosophy. You turn the world into a set of readings, because readings can be compared, and comparisons can be plotted, and plots can be used to predict. Prediction is the closest thing humans have to comfort that does not require a blanket, but the truth is quieter. Measurement does not remove mystery. It gives mystery a ruler and lets you discover how deep the mystery goes, because every instrument has limitations. Mercury freezes at a certain cold, and then your thermometer becomes a paperweight with aspirations. Alcohol thermometers work better in deep cold, but expand differently, and the line is less crisp. A barometer depends on gravity, which changes slightly with altitude and latitude, because Earth is not perfectly round and does not sit still. Your careful reading always carries a shadow of context, and early scientists, the patient people with ink-stained fingers, had to live inside that shadow. No instant graphs, no automatic logging. Just repetition, the same observation, performed calmly, thousands of times. A kind of devotion that looks like boredom from the outside. And boredom, in science, is often the door you walk through before you find something real. Because nature is consistent, but only if you show up consistently. So you become a person who wakes early, checks the thermometer, checks the barometer, notes cloud cover, notes wind direction. You write it down. You do it again tomorrow. Your neighbors think you are strange. They are not entirely wrong. But you are building a diary the sky cannot erase. And in time, those diaries add up. They become climate records. They become the story of seasons and droughts and the long moods of oceans. They become a way to notice when the planet is changing its habits. Slowly, quietly, while everyone argues about louder things. Even boring data is a lullaby like that. Steady, predictable, a repeated rhythm that tells you the universe has rules, even when it does not have mercy. And speaking of rules with no mercy, there are places on Earth where heat stops being cozy, where it stops being the pleasant warmth of a workshop furnace across the room. It becomes pressure, weight, exhaustion. So you step out of the instrument room and into the hot places. You stand in a desert first, because humans love simple metaphors. The sky is wide and indifferent. The ground is pale, cracked, or sandy, depending on which flavor of emptiness you purchased. In the day, sunlight lands on you like a steady hand pressing down. Not striking, not stabbing, just constant. Photons arrive, and your skin absorbs them, and your temperature begins to climb. You sweat, and if the air is dry, the sweat evaporates quickly. You cool. You might even feel comfortable, briefly, as long as you have water and shade and good timing. But the desert has a hobby. It steals water, not dramatically, not like a wave. It steals water the way a paper towel steals a spill. Patiently, efficiently, without apology. Your breath is a moisture loss. Every exhale is water leaving you. Your skin, even without sweating, leaks. Not in droplets, in a quiet diffusion you never see. The air is thirsty, and it drinks. And because nights can be cold, deserts also punish anyone who confuses heat with safety. You can bake in the day and shiver at night, under the same stars. It is a reminder that temperature is not a personality. It is a balance of energy in and energy out. In the day, the ground absorbs sunlight and radiates heat back upward. At night, the heat escapes into space because there are fewer clouds to trap it. The desert does not hold on to warmth. It just passes it through like a careless host. Now you trade the desert for humidity, and the vibe changes. You enter air that feels thick, though it is not thicker in the way soup is thicker. It is thick in sensation because evaporation is choking. The air is already crowded with water vapor, and your sweat molecules struggle to leave. They cling to your skin longer. You feel wet. You feel glazed. And you do not cool well. This is why humid heat can be more dangerous at lower temperatures than dry heat at higher ones. Because the mechanism matters. Your body does not need the air to be hotter than you to suffer. It just needs the air to prevent you from shedding heat. This is where heat illness becomes sneaky. You might be sitting still, drenched, thinking you are doing the right thing, but your core temperature can still creep upward. Your brain starts to misfire. Your judgment gets sloppy, and then you may stop sweating, which is an alarm you might not hear because you feel strangely calm right before things get serious. Humans learn to survive this with boring tricks. Timing, for one. Work early, rest at midday, move again when the sun lowers its stare. Shade, which is more powerful than it looks because it blocks direct radiation. Airflow, even a hand fan, because moving air helps evaporation when evaporation is possible. Cloth that covers skin, not to trap heat, but to reduce sunlight and slow water loss. Community habits, because heat kills lonely people first. Someone notices you slurring words. Someone insists you drink. Someone makes you sit down. Survival is often social long before it is heroic. And still, even with all that, the hot places remain a negotiation. The physics does not care about your plans. It cares about gradients, humidity, and the relentless accounting of energy. But if heat can overwhelm you softly, cold can do the same. It just uses the opposite direction. So you let the scene cool down and you listen to the slow logic of freezing. Cold is not a monster that leaps at you. Cold is a subtraction, a steady removal of the warmth you assumed was yours. You step into wind, and it does not feel like temperature at first. It feels like insistence. Wind strips away the thin, warm layer of air your skin tries to keep. That boundary layer is your tiny personal coat, made of trapped air. When wind steals it, your body has to heat new air again and again. It is like trying to warm your bed while someone keeps changing the sheets. So wind makes cold feel sharper, even if the thermometer says the air temperature has not changed. This is the reason for wind chill, which is not a new temperature, but a new rate of heat loss. Your nerves report speed. They report danger. They do not report the tidy number on a weather app. In mild cold, you cope easily. You pull your shoulders in. You rub your hands. You generate heat with movement. But the cold keeps subtracting, and your body keeps budgeting. Blood leaves your fingers and toes first. Your hands lose dexterity. Buttons become complicated. Zippers become philosophy. And in deeper cold, tiredness arrives. It feels comforting, like permission to stop struggling. This is the trap. As your core cools, your brain slows. You become less afraid, not because you are safe, but because fear requires energy. People in severe cold sometimes remove clothing in confusion, a phenomenon called paradoxical undressing. The name is clinical. The reality is tragic. It can happen when blood vessels suddenly dilate, creating a flush of warmth in the skin. A final, misleading warmth, like a kindly lie. Your brain believes it. And then, if the cold continues, consciousness fades. The good news is, you may not feel much at the end. The bad news is, that is exactly the problem. Cold is a slow thief that steals your ability to notice you are being robbed. So humans respond with boring, effective ideas. Layers? Because trapped air is insulation and air is free. Dry socks? Because water conducts heat away faster than air, and wet feet are an argument you will lose. Shelter? Because cutting wind is often more important than adding heat. Food? Because your furnace needs fuel. And not being alone, because a second brain can notice what your brain misses. These are not romantic solutions. They are practical. They work. And they have kept millions of people alive in climates that do not care about human dignity. Once you have felt how air can hurt, hot or cold, you start paying attention to air itself. Because it is strange. When you think about it, an invisible ocean pressing on you all day, and you do not feel it. So you begin to sense the weight above your head. Not emotionally, physically. You live at the bottom of an atmosphere that stacks upward for miles, a column of gas held by gravity. Air molecules move fast. They bounce and collide like restless insects, and each collision transfers tiny amounts of momentum. Pressure is what you call the result, a continuous pushing made of countless tiny hits. You do not feel it because you are pressurized too. Your body contains fluids and gases that push back. Equilibrium is comfort again, that moment where the argument ends. But you can notice pressure when it changes. On an airplane, as the cabin climbs, your ears complain. The eustachian tubes try to equalize the pressure between your middle ear and the outside air. When they lag behind, you feel that pop, that sudden shift. It is not a sound. Exactly, it is a physical correction. Air moving where it was not moving before. And pressure changes matter in quieter ways too. Boiling, for example, is not only about heat. Boiling is about pressure. Liquid water boils when its vapor pressure matches the surrounding pressure. In simpler words, it boils when bubbles can form and survive, instead of being crushed shut. At high altitude, surrounding pressure is lower, so bubbles win sooner. Water boils at a lower temperature. This is why cooking can be annoying in the mountains. Your pot is boiling, but your food is not cooking as fast, because boiling is not the same as hot enough. Meanwhile, in a pressure cooker, you trap steam and raise the pressure. Now water can get hotter before it boils. Cooking speeds up because chemistry likes heat and proteins surrender faster. So pressure is not just a weather detail. It is a lever on everyday physics. Breathing is another pressure story you live inside. You inhale because your diaphragm moves down, expanding your chest cavity. This lowers pressure inside your lungs slightly compared to outside air. So air flows in, not because you suck it like a straw, but because pressure differences move gases automatically. You exhale when muscles relax, pressure rises, and air leaves. A simple pump, a soft bellows. And the strange part is that you do this without ever feeling the atmosphere as a hand on your chest. You only notice the air when it is missing, or misbehaving, or moving too quickly. Most nights, it just sits there, heavy and generous, letting you borrow oxygen without a receipt. You forget that every breath is a chemical negotiation, signed in blood. You pull in air that is mostly nitrogen, a gas that watches the whole process and contributes nothing. Nitrogen is the quiet coworker who never helps, but still takes up most of the room. The useful part is oxygen, only about 1/5 of the mix, and yet it runs your entire metabolism. You inhale it like it is free. It is not free. It is merely abundant, at least for now. Inside your lungs, the air spreads into branching tubes, then into tiny sacs called alveoli. Alveoli is Latin-flavored science language for little cavities. In human terms, it means a sponge made of delicate bubbles. Those bubbles are lined with tissue so thin it feels rude to call it a wall. 1 cell thick in many places, just enough to keep your blood inside you. On the other side of that thin lining, capillaries wrap around like netting. Capillaries are hair-thin blood vessels built for trading gases. And you, tonight, are the trade. Oxygen diffuses from the air into the blood because physics loves gradients. Carbon dioxide diffuses out of the blood into the air because physics loves gradients even more. Carbon dioxide is the exhaust gas of your cell fires. The more you burn fuel, the more you make. If it builds up, the blood gets more acidic, and your brain notices. Your urge to breathe is driven more by carbon dioxide levels than oxygen levels, which is charming in a cynical way. You are not motivated by what you need. You are motivated by the discomfort of what you cannot tolerate. That is a very human design philosophy. And the atmosphere makes all of this possible because the pressure is high enough to pack molecules close together. At sea level, each breath is crowded with gas molecules. As you climb a mountain, the pressure drops and the crowd thins out. The percentage of oxygen stays about the same, but each lungful contains fewer oxygen molecules. So your blood loads less oxygen with every inhale. Your body can adapt slowly by making more red blood cells and adjusting breathing. But if you climb too fast, your brain starts to complain. Headache, nausea, fatigue, a fog that feels like bad sleep. Congratulations, your neurons are running on a reduced oxygen budget, and your neurons are not known for their patience. This is also why pilots and high-altitude climbers carry oxygen. Not because oxygen is glamorous, but because biology has limits and does not negotiate. If you go high enough, the pressure drops so much that water begins to act differently. Not only in pots, in you. At very low pressure, the boiling point of water falls below body temperature. So the water in your tissues wants to boil. This is called ebullition, a word that sounds like a bubbly drink and behaves like a nightmare. You do not actually boil like a kettle because your skin holds pressure in for a while. But fluids can form gas bubbles, swelling tissues, stressing blood vessels, making everything inefficient and angry. A spacesuit is not a fashion choice. It is a portable pressure chamber because your body prefers not to fizz. Even before that point, you meet another pressure problem: decompression sickness. If you go from high pressure to low pressure too quickly, dissolved gases come out of solution. The main troublemaker is nitrogen, the same useless coworker from earlier. Under pressure, nitrogen dissolves into your blood and tissues. When pressure drops, it forms bubbles, like opening a shaken bottle. Those bubbles can lodge in joints, causing pain, the bends. They can block blood flow, irritate nerves, cause dizziness, paralysis, death. It is a boring physics rule with dramatic consequences. Divers learn it the hard way, or they learn it from someone else's hard way. Slow ascent is not just cautious, it is molecular courtesy. You are giving nitrogen time to leave your body. Through your lungs, one gentle exhale at a time. So yes, air is invisible, but it is not gentle by default. It is only friendly within a narrow band of pressure, temperature, and composition. And within that band, you live your whole life and call it normal. You call it the weather. You call it breathing. You call it not thinking about it. But the moment you step outside that band, the atmosphere reminds you that comfort is an engineered illusion. And speaking of engineered illusions, nothing screams human optimism like taking a toxic metal and using it as a measuring tool. The same substance that can damage your nerves also helped you predict storms. Mercury, again, slipping into the story like a familiar villain who never got arrested. Because Mercury shows up wherever you need a dense liquid that behaves predictably. In thermometers, yes. In barometers, definitely. And once you start measuring air with Mercury, you start asking what air is made of. Because if you can weigh it, if you can press it into a column, then maybe you can inventory it. Chemistry is the quiet bookkeeping underneath the sky. It counts atoms the way an exhausted accountant counts coins, slowly, carefully, and with no romance. Early chemists did not have modern instruments. They had glassware, flames, balances, and stubbornness. You heat substances. You collect gases. You see what combines with what. You weigh before, you weigh after. If the weights match, you trust that matter is conserved. If they do not, you look for leaks, or you admit you were wrong, which is rarer. In the 1700s, people argued about what air even was. Some thought it was a single element with different moods. Then careful experiments started splitting that idea apart. You trap a gas from burning charcoal and find it suffocates flames and animals. You trap another gas from heating certain minerals and find flames burn brighter in it, it becomes clear that air is a mixture, a crowded room of different molecules. Oxygen is one tenant, nitrogen is another. There is argon, mostly inert, like a lamp that is always off. There is carbon dioxide, only a small fraction, but with an outsized influence on climate and blood chemistry. And there is water vapor, variable and moody, the source of clouds and sweat problems. Knowing this does not make you safer by itself, but it makes you harder to fool. It makes the world feel more mechanical, less haunted. Though the truth is, mechanics can be its own kind of haunting, because once you can name the gases, you start noticing when something that is not supposed to be there shows up. And mercury is one of those things. Mercury is an element, atomic symbol Hg, from hydrigyrum, meaning watery silver. Watery silver is a flattering name for a substance that can ruin your life. In its elemental form, it is a liquid metal at room temperature. That alone makes people treat it like a toy. It rolls into beads, it shines, it feels magical. It is the kind of thing a person might touch just to prove they can. And for a long time, people did. Thermometer makers, hat makers who used mercury compounds in felt processing, giving us the phrase, mad as a hatter. Gold miners who used mercury to form amalgams with gold, then heated it to drive off mercury vapor. Congratulations, you just inhaled your profits. The danger comes in several flavors. Elemental mercury vapor is the big one for workshops and spills. It evaporates at room temperature, slowly but constantly. Warmth increases the vapor, which is rude because workshops are warm. When you inhale mercury vapor, it crosses into the bloodstream easily through the lungs. It can pass into the brain, where it interferes with nerves and neurotransmission. Tremors, irritability, memory problems, insomnia, a personality that frays at the edges. A person can become anxious, depressed, angry, not because they are weak, but because atoms are rearranging their nervous system. This is why mercury poisoning can look like a moral failing. It is not. It is chemistry doing what chemistry does, without concern for your reputation. Then there are mercury salts, inorganic mercury compounds. These can damage kidneys, irritate the digestive tract, cause pain and weakness. And then there is methylmercury, the organic form that shows up in food chains. This is the one that turns an industrial mistake into a generational tragedy. Certain microorganisms in water can convert mercury into methylmercury. That molecule binds to proteins and accumulates in living tissue. Small organisms absorb it. Fish eat them. Bigger fish eat those fish. The mercury concentrates because bodies do not have an easy way to get rid of it. This is biomagnification, which is a polite word for the way poison climbs the food ladder. If you eat high on the food chain, you inherit the chemistry of everything below you. Most of the time, in most places, the doses are low, but sometimes history gives you a concentrated example. Minamata, Japan. In the mid-1990s, industrial wastewater carried mercury into a bay. Microbes converted it. Fish accumulated it. People ate the fish. Neurological damage followed: numbness, tremors, difficulty speaking, hearing, seeing. Children were born with severe developmental problems. Cats staggered and convulsed. as if the whole shoreline had become cursed. It was not a curse. It was accounting. Atoms added in the wrong place, multiplied by time, turned into suffering. Mercury does not belong in you, not because you are pure, but because your nervous system is exquisitely sensitive. Neurons work through electrical signals and chemical gradients. Mercury interferes with proteins, binds to sulfur groups, disrupts enzymes. It is like throwing sand into a clock and acting surprised when time becomes unreliable. And the hardest part is still the invisibility. Mercury vapor does not smell like danger. A contaminated fish does not taste like warning. Nature does not label its hazards. It does not print skull icons on shiny liquids. So modern safety had to be learned the slow way, through tremors and headaches, through ruined careers and ruined families, through lawsuits and denials, and eventual acceptance. Ventilation became normal. Gloves became normal. Fume hoods became normal. Spill kits with sulfur powders that bind mercury became normal. And eventually, the tools changed. Because once you understand that a measuring device is quietly poisoning its maker, you begin to rethink the romance of tradition. You start asking if there is a way to measure temperature without a metal that behaves like a ghost. And that question leads you out of the glass workshop and into the quiet hum of electronics. A modern thermometer does not need a silver column. It needs a material that changes predictably with temperature. Many do this by changing electrical resistance. Resistance is how much a material resists the flow of electric current. In many metals, resistance increases as temperature rises. The atoms vibrate more, and electrons bump into that vibration, losing smooth passage. So, temperature becomes a change in a number your circuit can read. A common sensor type is a thermistor. Thermistor means thermal resistor, which is almost too honest. In one kind, called NTC, negative temperature coefficient, resistance goes down as temperature goes up. In another kind, PTC, it goes up with temperature. These are made from ceramic or polymer materials engineered to respond strongly to small temperature changes. You place it against skin, or inside food, or in a wall thermostat. It reports temperature as voltage changes in a circuit. No liquid metal, no vapor. Just electrons doing their quiet work. Another approach is a resistance temperature detector, often platinum. Platinum is used because it is stable and predictable, not because it is fancy. A platinum wire changes resistance smoothly with temperature. You measure that change with careful electronics, and you translate it into degrees. In industrial settings, thermocouples are common. A thermocouple is two different metals joined together. When there is a temperature difference between the junction and the other ends, a small voltage appears. This is the Seebeck effect, a physics fact with a suspiciously friendly name. The voltage is tiny, but measurable. And it tells you temperature differences. It is rugged, simple, and good for high temperatures where delicate sensors fail. Then there are infrared thermometers, which do not even need contact. Everything above absolute zero emits infrared radiation. Your skin glows in infrared constantly, like a low-drama campfire. An infrared thermometer measures that glow and estimates temperature. It is quick, which makes it convenient, and also a little misleading. Because it measures surface temperature, and your core temperature is a deeper story. But for many purposes, it is enough. And enough is what most of civilization runs on. You do not need perfect truth to keep a baby safe or cook a meal. You need consistent, reliable signals that let you act before trouble arrives. This is what modern sensors are really for. Not enlightenment. Prevention. A thermostat listens to temperature and clicks a heater on or off. A refrigerator monitors its interior and keeps food from becoming a microbial carnival. A weather station sits on a pole, far from your attention, collecting temperature, humidity, pressure, wind. A slow diary written by machines that never get bored. And yet, the same principle remains. Measurement is still negotiation. The sensor must come to a shared state with what it measures, or interpret radiation, or compare voltages. There is always calibration. There is always drift. There is always the need to check the checker. Even digital devices can lie, not maliciously, but mechanically. A cheap sensor can be off by a small amount, and that small amount can matter. Medical thermometers require accuracy because fever lines are not philosophical. Industrial process controls require accuracy because chemical reactions can run away if you misread temperature. So, we built systems and standards and reference thermometers. We built laboratories where temperature itself is treated like a sacred thing. Not because we worship heat, but because we fear what happens when we ignore it. And you can feel the difference in the culture. In the old workshop, mercury was handled like a familiar friend. In a modern lab, mercury is treated like a liability that happens to be useful. If mercury is present, it is contained, labeled, monitored. It is not allowed to wander, because now we know that invisible does not mean harmless. Now we respect vapors the way earlier people respected wolves. And still, mercury remains in the world because old tools break and old pollution persists. There are still contaminated sites. There are still fish advisories. There are still people who find an antique thermometer and crack it open out of curiosity. Congratulations, you just released a toxin onto your carpet. The correct response is not panic, it is method. Do not vacuum, because vacuuming spreads vapor and breaks droplets into smaller beads. Ventilate the area. Use proper cleanup materials. Collect beads carefully. Dispose according to hazardous waste guidance. This is not bedtime material exactly, but it is real, and reality is sometimes calming in its clarity, because once you know what to do, the fear becomes smaller. Knowledge does not make the world safe. It makes you less surprised by danger, and surprise is what makes danger feel like horror. Speaking of horror, it is worth remembering how close comfort sits to catastrophe. In ordinary life, you are lying in bed, warm enough, breathing easily, and all of that is maintained by systems you rarely think about. Indoor heating, insulation, clean water, food safety, medical standards, sensors and regulations, and boring people doing boring checks. The universe is uncaring, but your house is full of tiny acts of care, performed by strangers you will never meet, not because they love you, because they love predictability, and predictability happens to keep you alive. You can trace a line from a fever thermometer to public health, from barometer readings to storm warnings, from humidity sensors to building codes that prevent mold, from pressure gauges to safe boilers that do not turn homes into shrapnel. these are not heroic narratives. They are cumulative corrections. The world gets safer in slow increments, like a long series of small apologies. And while we are here, it is worth drifting back to the idea of air pressure, because Mercury taught us that too. A barometer, whether mercury or aneroid, is a tool for reading the sky's intentions. An aneroid barometer does not use liquid. It uses a sealed metal capsule that flexes as pressure changes. Those tiny flexes move gears and needles, translating invisible weight into a dial reading. It is beautifully mechanical, like a watch that tells you whether the atmosphere is in a good mood. Low pressure often means rising air, cooling, condensation, clouds, storms. High pressure often means sinking air, warming, clearing skies. Not always, but often enough to be useful. And the usefulness is the point. A fisherman does not need a dissertation on atmospheric circulation. They need to know if the wind is about to become a problem. A farmer does not need the molecular structure of water vapor. They need to know if frost is coming. Measurement is a bridge between the indifferent sky and your soft plans. And there is something quietly comforting about that. Not because it gives you control, because it gives you warning. Warning is a kind of kindness, even when it comes from a machine. So you end up living in a world full of quiet sensors. Smoke detectors sniff for particles. Carbon monoxide detectors listen for a gas you cannot smell, but that loves to steal oxygen's job. Thermostats listen for temperature changes and decide when to push heat into rooms. Refrigerators hum, not for beauty, but to slow the metabolism of bacteria. Your phone, sitting nearby, contains sensors for acceleration, light, magnetic fields, sometimes even pressure. A pocket laboratory used mostly for scrolling. And this is the modern version of the old instrument room. Not a shelf with a mercury tube, but a network of devices that watch your environment all the time. The world is still mysterious. It is just more monitored. Now, to be fair, monitoring has its own downside. Knowing the number does not always bring peace. Sometimes it brings obsession. People check weather apps like they are reading omens. They watch indoor air quality sensors and start arguing with their own living room. They track sleep with watches and feel judged by graphs. Congratulations, you turned rest into homework. But used gently, these tools are just what the old thermometers were. Translators. They take a mess of reality and turn it into a single polite signal you can live with. And you, soft animal that you are, start trusting the signal more than your own senses. You glance at a thermostat and decide you feel cold, even if you were fine. You see a fever number and decide you feel afraid, even before the shivering starts. The display becomes the story, and your body becomes a footnote. But the story those sensors tell is still written in matter, still written in atoms, vibrating, electrons bumping, molecules trading places. Even the quietest modern device is just a different kind of glass tube, a different way to coax the universe into confessing. And since you have let your life be measured this far, you might as well know what the most calming part is. You do not need to master any of it. You only need the room to stay warm enough and the water to stay safe enough. That is the secret economy of modern comfort. 1 million tiny measurements done by people you will never meet, so you can stay ignorant in peace, which is, honestly, a beautiful arrangement because ignorance is not always a failure. Sometimes it is a luxury you earned by living late in the timeline. Still, the timeline has a sense of humor. It gave you safe digital sensors and then left mercury in the walls anyway. In old switches, in old bulbs, in old labs, in old spills that never quite got cleaned right. In river sediment, in ocean fish, in the patient chemistry that keeps converting and concentrating. So you drift back to that metal one more time, not out of fear, but out of realism. Mercury is not evil. Mercury is just extremely good at being in the wrong place. You can picture it in your mind, the way it moves. It does not smear like water. It fractures into beads, each bead a tiny mirror, each mirror convinced it is whole. That is surface tension, the liquid skin holding itself together. The atoms at the surface have fewer neighbors to cling to, so they cling harder inward. It makes mercury look clean. It makes it look contained. It makes it look like something you could scoop up and be done with. And that is the first lie mercury tells you. Because the part that hurts you is not the bead, it is the invisible escape above it. A slow exhale of atoms into air. Even at room temperature, mercury has a vapor pressure, which is a fancy way of saying it cannot stop trying. The warmer the room, the more it tries. Workshops were warm, so the air above the dish was always haunted. Not haunted by spirits, haunted by physics. When you inhale mercury vapor, it slides past your defenses with embarrassing ease. Your nose is not a chemical analyst. Your throat does not have a mercury alarm. Your lungs are designed for gas exchange, and mercury vapor is a gas. So it crosses those thin alveolar walls and enters blood like it belonged there. Blood carries it, because blood carries everything that fits. And then the metal meets the nervous system, which is basically electrical wiring wrapped in fat. Neurons fire by moving ions across membranes, sodium and potassium trading places like anxious commuters. Mercury does not need to smash the wiring to ruin the signal. It only needs to gum up the proteins that keep the signal clean. Mercury loves sulfur. Many proteins have sulfur-containing groups that act like hinges and locks. Mercury binds to them, changes their shape, makes them less useful. The effect is not always dramatic on day one. It is cumulative, like dust in a fan. At first, the fan still spins. Then it starts to wobble. Then it screams, and you pretend it is fine until it stops. That is why old descriptions of mercury poisoning are so unnerving. A person does not collapse in a neat, cinematic way. They change. They become irritable, forgetful, shaky, tired. Their handwriting gets messy. Their patience gets shorter. Their sleep gets worse, which is a cruel joke because bad sleep makes everything else worse too. In some older medical notes, the tremor was called Hatter's Shakes because the felt hat industry used mercury salts and the workers paid for fashion with their motor control. And even when elemental mercury was the main exposure, the nickname stuck, not because anyone solved the problem. Because humans like naming things more than fixing them. The fix, when it finally came, was boring. Ventilation, capture, containment, rules. The kind of rules people hate until the alternative is shaking hands that cannot hold a spoon. And those rules exist now in the quiet background of your life. You do not see the safety data sheets. You do not see the waste containers. You do not see the training videos that teach a lab student not to chase droplets with a finger. You just benefit from the result. Mercury thermometers got phased out in many places. Hospitals switched to digital probes and infrared scans. Factories replaced mercury switches with other designs. Some countries banned certain mercury products entirely, not because mercury became more toxic, because humans finally became less sentimental about it. Though, of course, sentimentality still leaks in. People keep antique thermometers in drawers. People keep old barometers on walls, their glass tubes still heavy with metal, and occasionally, someone drops one. So you should know, calmly, what the physics of a mercury spill looks like. Not in a dramatic way, in a practical way. Mercury is dense, so it falls into cracks. It rolls under baseboards. It hides in carpet fibers. It breaks into smaller beads with impact. And smaller beads have more surface area. More surface area means more evaporation. Congratulations! The spill just learned how to breathe faster. This is why vacuuming is a bad idea. A vacuum makes airflow. Airflow increases evaporation. The motor can warm the mercury too, and the vacuum can spread tiny beads, turning one problem into a distributed system. The best approach is slow, careful collection. With proper tools. Ventilation matters because dilution is real, and disposal matters because you do not want the beads relocating to a landfill where they can keep migrating. This is the modern mindset in miniature. Not panic. Process. Treat invisible hazards as if they are real, because they are. And once you accept that, you start seeing the world differently. Not as a safe place, as a place made safe by constant maintenance. That is a more honest comfort. Now, speaking of maintenance, there is a kind your body does that feels almost tender. Because while humans were figuring out not to poison themselves with instruments, your cells were quietly learning how to survive your lifestyle. You are a warm animal with a nervous system that refuses to shut up. So your body runs its own sensor network. It measures temperature, blood acidity, oxygen levels, blood pressure, sugar levels. Not with screens, with receptors, hormones, and electrical impulses. Your hypothalamus, that small, opinionated lump, reads temperature signals from inside your body and from skin. It decides whether to open blood vessels, close them, sweat, shiver. It does not ask your permission. It does not care about your schedule. It is an ancient thermostat with one job, and it is not interested in your productivity. Your pancreas measures glucose in blood and releases insulin like a quiet financial regulator. Too much sugar circulating, and it tells cells to store it. Too little, and it tells the liver to release reserves. Your carotid body's little sensors near major arteries monitor blood chemistry. They help drive breathing when carbon dioxide rises, when oxygen falls. They are the reason you inhale again, even when you are not thinking about it. So when you strap a smartwatch to your wrist and track your sleep, you are just imitating what your body has always done. Only your body does not generate graphs. It generates feelings, and feelings are the original user interface. They are not always accurate, but they are fast. Pain, thirst, hunger, fatigue, warmth, chill. These are signals, crude but effective. The problem is, that modern life can confuse them. Air conditioning makes thirst less obvious. Soft beds make tiredness feel like a moral choice. Bright screens make night feel like day. Congratulations, your ancient sensors are being gaslit by good lighting. Still, you keep going because the human talent is adaptation. And adaptation is mostly boring. You change little habits. You add a blanket, you open a window, you set the thermostat 2 degrees lower. You drink water without drama. You learn slowly what keeps you comfortable. And this is where the scientific story becomes almost sweet in its cynical way, because the people who made dangerous thermometers were not monsters. They were working with the pages they had. They were translating heat with the tools available. They did not know what mercury vapor was doing to their nerves. They only knew the metal behaved nicely in glass. They valued precision, and mercury offered it. This is an important pattern in science and engineering. You build something that works, and then you discover what it costs. Sometimes the cost is money. Sometimes it is time. Sometimes it is a generation of tremors. And then, if you are lucky, you revise. You keep the function and you reduce the suffering. That is not progress as a fireworks show. That is progress as a slow lowering of unnecessary pain. And it happens through paperwork and standards and committees, through people who argue about decimal points, through people who insist on ventilation rates and exposure limits, the kind of people nobody thanks at dinner parties. Which is fine. They are not doing it for applause. They are doing it because physics is not forgiving and biology is fragile. Now, since you have let the universe be quantified around you, you can zoom out again, gently, because temperature is not just a human comfort variable. Temperature is a universal tax. In every system, energy spreads out. Hotter things tend to cool. Cooler things tend to warm. Not because they want to, because there are more ways to be mixed than separated. This is the flavor of the second law of thermodynamics. Though you do not need the math tonight, you only need the vibe. The vibe is that order is expensive. Keeping your room at a stable temperature is work. Keeping your body at a stable temperature is work. Keeping a thermometer calibrated is work. And the universe keeps trying to make you pay. Heat leaks, energy disperses, gradients flatten. Your house loses warmth through walls, windows, floors. Insulation slows it, but does not stop it. So your heater cycles on, pushes energy back in, holds the line for a while. This is civilization in miniature. A constant fight against the default drift. And yes, there is something calming about admitting that drift exists, because once you accept the drift, you stop expecting permanence. You stop being offended by entropy. You simply plan around it. You wear layers. You store food properly. You vent the workshop. You replace the mercury thermometer with a thermistor and move on. Now, one of the strangest comforts of modern science is how often it comes down to replacing one dangerous material with another that is merely less dramatic. Because your electronics are not made of kindness. They are made of metals, plastics, ceramics. They involve mining, refining, manufacturing. They involve solder and solvents and batteries that would love to burn your house down if treated poorly. But the risks are better understood. They are compartmentalized, and you live in a world where many hazards are pushed far away from your bed. That is not purity. That is logistics. So the Mercury Thermometer maker fades into history, and you inherit the benefits. And what you inherit, most of all, is the comfort of knowing enough. Not everything. Enough. Enough to trust the heating system. Enough to trust the refrigerator. Enough to trust that a number on a screen is probably close to the truth. Enough to know what to do when it is not. This is the part that tends to get lost when people talk about science as genius. Science is also maintenance. It is a culture of checking, cleaning, repeating, calibrating. It is a habit of admitting error and correcting it, which is, frankly, a better bedtime story than most hero myths, because it suggests you do not need to be special to make things better. You need to be consistent. You need to be willing to be bored. A technician who calibrates sensors in a hospital is doing a kind of public kindness. A health inspector checking refrigerator temperatures in a restaurant is doing quiet violence prevention. A meteorologist maintaining weather stations is building an early warning system for storms that do not care about your plans. None of these people are usually celebrated, and yet your comfort depends on them. Your safety depends on them. You are surrounded by invisible work, which is ironic given how much trouble invisible hazards caused in the Mercury era. Now, since you are lying still, it is easy to forget how much your world is actively managed. So take a small mental walk through it, not as gratitude, but as inventory. Your indoor air is held at a pressure close to the outside because your house is leaky by design. That leakiness prevents moisture buildup, prevents suffocation, prevents weird pressure differentials that would make doors fight you. Your plumbing delivers water that has been treated, filtered, and disinfected. Disinfected means deliberately made hostile to microorganisms. Chlorine is often involved, a chemical with its own dangerous personality used carefully at low levels, because nature is full of microbes that would love to colonize your intestines. The water heater warms your water, and a thermostat prevents it from becoming scalding. Scalding is another quiet physics rule. Heat transfer from hot water to skin is fast because water conducts heat well and clings to you. So your system is designed to keep it within safer limits. Even your mattress is part of thermal engineering. Foams trap air differently. A thick comforter changes convection, changes radiation loss, changes your skin temperature, and you experience all that as a simple feeling, cozy or not cozy. Your body makes micro adjustments through the night. A foot slips out from under the blanket to dump heat, a shoulder tucks in to conserve it. You do not plan it. You just do it. And in the background, the same physics is still running. Molecules jostling, energy drifting, sensors translating, systems correcting. This is why you can let your mind loosen a little. Not because nothing can go wrong, because so much is quietly preventing wrongness right now. Now, if you want a small, darkly amusing detail to hold on to, consider how much of modern comfort exists because humans are terrified of being surprised at night. Fire alarms, emergency lighting, thermostats that prevent pipes from freezing, circuit breakers that trip before wires glow. Every device is a concession to the fact that you are unconscious for hours, and the universe would happily use that time to inconvenience you. So we built watchdogs, boring little guardians. And the oldest watchdog is still your own body. Your brain cycles through sleep stages, not as a spiritual journey, but as a maintenance schedule. Some sleep is lighter, some deeper, some full of dreams that feel like nonsense, because they are. Dreams are likely the brain doing file management while cutting the external feed. Memories get consolidated, emotional reactions get tuned, connections get tested. It is not mystical. It is just neural tissue trying to stay functional in a world that keeps demanding attention. And this is where the earlier thermometer story loops back in a quiet way. Because temperature affects sleep too. Your core body temperature tends to drop slightly at night. A small decline, not dramatic, but meaningful. It helps signal that it is time to rest. That is why a hot room can make sleep feel slippery. Your body is trying to cool, and the environment is arguing back. It is also why a warm shower before bed can help some people. It sounds backwards, but the warmth dilates blood vessels near skin. After you step out, heat can leave your body faster. Your core cools, and the brain reads that as night. Again, not magic, just gradients. The same language your Mercury thermometer used, spoken inside your flesh. And because temperature touches everything, it touches medicine in ways older people could barely imagine. Vaccines must be stored cold because proteins and delicate structures degrade with heat. Insulin must be handled carefully. Blood samples are transported with temperature control. Laboratories incubate cultures at specific warmth because microbes grow at their preferred settings. If you have ever seen a lab incubator, it is basically a luxury hotel for bacteria. A warm box with stable humidity, built to keep tiny organisms comfortable while humans plan their demise. Congratulations, you invented climate control to help germs flourish, briefly, for research. But that is science. You sometimes nurture the thing you fear, just to understand it. Now, the last thing worth doing before you drift deeper into the story is to notice how often the most ordinary materials are hiding strange behavior. Glass looks solid and reliable, but it is an amorphous solid, more like a frozen liquid than a perfect crystal. Metals feel cold because they conduct heat well, not because they are inherently colder. Air feels empty, but it has weight and pressure and composition, and your lungs are built around it. Mercury looks calm, but it evaporates and binds and disrupts. Even water, the polite background substance of your life, has bizarre habits. Ice floats, which is rare for solids because water expands when it freezes. That expansion is why pipes burst. It is also why lakes freeze from the top down, creating an insulating layer of ice that lets fish survive beneath. A small molecular quirk, hydrogen bonds forming a less dense structure, becomes the difference between life and dead ponds each winter. And once you accept that everyday materials are quietly strange, you stop being shocked by science. Science becomes the practice of noticing. Noticing that heat is motion. Noticing that pressure is collisions. Noticing that a shiny liquid can be toxic while looking harmless. Noticing that comfort is engineered and therefore fragile. But not fragile in a panicky way. Fragile in a manageable way, as long as people keep doing the boring work. And speaking of boring work, you can return for a moment to the old thermometer maker, not as tragedy, but as a portrait of routine. You can hear the tiny clink of glass rods laid on wood. You can smell the warm dust again. You can feel the steady heat from the flame. The maker repeats the same motion because repetition is how skill gets carved into muscle. Skill becomes a kind of autopilot, and autopilot is wonderful right up until the hazard is invisible. Your fingers learn the weight of the tube, the softness of hot glass, the exact moment it wants to sag. Your eyes learn the silver meniscus, that curved little smile at the top of the mercury column. Meniscus is the fancy term, and in human terms, it is the liquid refusing to be flat, because surface tension is mercury being stubborn. Even at rest, you tilt the tube and the line shifts, not because temperature changed, but because gravity is always part of the story. And you, tired apprentice of certainty, learn to hold it straight. That is the kind of knowledge people call craftsmanship. It is not wisdom. It is repetition plus consequence. Now picture what happens when consequence is delayed. A burn teaches immediately. A cut teaches slowly, which means it teaches thoroughly. You can do everything right in the way your era defines right and still lose, because the era has not learned to treat air like a delivery system for poison. So the workshop stays warm, the windows stay shut in winter, and the vapor keeps rising, like a problem that learned patience. This is where modern sensors feel almost like a moral upgrade, not because humans became kinder, but because we became more accurate about what hurts. And accuracy, boring as it is the beginning of mercy. You replace the glass tube with a little bead of engineered ceramic. You replace the shimmering metal with a quiet electrical signal. You keep the function and you reduce the suffering. That pattern repeats across modern life in small, almost unromantic steps. Lead leaves gasoline, slowly. Asbestos leaves insulation, slowly. Mercury leaves hospital rooms, slowly. The world does not pivot, it shuffles, and the shuffle is held together by standards. A standard is just an agreement that refuses to be casual. It is a rule that says, if you want to sell a thermometer, your numbers must mean the same thing as mine. Not approximately, not poetically, but close enough to trust in a fever. So somewhere, far from the old workshop, temperature becomes a carefully guarded reference. Not a feeling, not a guess, but a traceable chain. Traceable means you can follow the calibration back, step by step, to a known source. A lab thermometer is checked against a better thermometer. That better thermometer is checked against an even better one. Eventually, the chain leads to national standards laboratories, where people spend their lives arguing with heat. And their arguments are quiet. They use fixed points again, but with more discipline than a pot on a stove. They use the melting point of pure substances. They use the triple point of water, which is water's rare moment of being solid, liquid, and gas at once. Triple point sounds like a circus trick. In human terms, it is water finding a precise balance between temperature and pressure. It happens at a specific condition, repeatable, calm, and picky. And because it is picky, it is useful. It becomes a reference that does not care about your kitchen, your altitude, your weather. This is how modern temperature scales stay coherent across continents, not through inspiration, through ritual. And of course, the universe still laughs at our rituals, because temperature is not just a number you assign. Temperature is tied to deeper ideas, like the limit of cold. Absolute zero is the name we give to the theoretical point where thermal motion is minimized. Minimized, not necessarily eliminated, because quantum mechanics refuses to let anything be perfectly still, even at the coldest imaginable place. Particles keep a little jitter, a permanent fidget. So absolute zero is not a destination you reach like a mountain summit. It is a wall you approach asymptotically, forever. Asymptotically is a long word for never quite touching. In human terms, it is the universe saying, "Nice try, now watch me keep one last secret." And yet, we get close. Laboratories cool atoms until they behave in strange collective ways, like a Bose-Einstein condensate. That phrase sounds like a dessert. It is actually atoms collapsing into the same quantum state, moving like a shared dream. At that point, temperature is no longer just comfort and fever. It is the knob that tunes reality into different phases of behavior. But you do not need that tonight. Beyond the mood is that measuring temperature led us from workshops into quantum weirdness. Without ever losing the thread, the same question, asked calmly for centuries, kept unfolding into stranger rooms. And still, most of your life happens in the dull middle range, warm enough for enzymes, cool enough for sleep, stable enough that you can ignore the physics and call it normal, which brings you back to the soft landing of knowing enough. You do not need to hold the whole chain of calibration in your head. You only need it to exist somewhere, tended by bored professionals. You only need your thermometer to be close enough to reality that your decisions are not gambling. And this is where the story gets gentle again, because the whole point of measurement is not domination. It is timing. If you can detect a fever early, you can respond early. If you can detect a freezer warming, you can save food before it becomes dangerous. If you can detect a boiler overheating, you can shut it down before it becomes a demolition event. Early warning is the practical cousin of control, and it is much easier to afford. It is also easier to live with, psychologically, because total control is a fantasy that turns into stress. Warning, on the other hand, lets you stay human. It lets you be slightly late, slightly imperfect, and still safe. So modern comfort is built from thresholds. The thermostat does not care about the exact temperature down to a whisper. It cares whether you cross the line that demands action. The refrigerator does not need poetry. It needs a set point. The smoke alarm does not need to identify the brand of catastrophe. It needs to notice particles rising above normal. This is science as companionship, in its blunt way. A collection of simple decisions automated so your mind can go dark for a while. And while your mind goes dark, your body keeps running its own thresholds. Your blood pressure drifts. Your breathing deepens and shallows. Your core temperature slides slightly downward, then steadies. Sleep is not an off switch. It is a low power mode with maintenance scripts. And maintenance scripts are what keep a fragile animal from falling apart. The most calming thought is that you do this every night and you rarely notice. Not because it is trivial, because it is well designed by evolution's messy trial and error. Now, because you are the kind of person who listens to a story about Mercury for fun, you might enjoy one more quietly strange detail. Mercury is not just toxic, it is also a great symbol of how scale changes behavior. A big bead rolls like a ball bearing, a tiny bead hides like glitter. A thin film evaporates fast enough to matter. Surface area is the lever here. More exposed surface means more atoms can escape into air at once. This is why breaking mercury into droplets makes a spill worse, not better. And this is the same logic that makes dust explosions possible. A pile of flour sits there like a harmless ingredient, but flour dispersed in air becomes a cloud of surface area. One spark and the reaction runs fast because oxygen can reach everything. Congratulations, you turned baking supplies into a bomb. With geometry, it is always like this in science. A change in shape becomes a change in danger. A change in size becomes a change in rules. A thermometer is safe when sealed. A thermometer is a problem when broken. So the modern world tries to keep hazards locked into stable forms. Batteries are sealed so you do not touch the chemistry. Refrigerant is sealed so you do not breathe it. Insulation is sealed so you do not inhale fibers. And the moment the seal fails, you learn what the object really was. A container for a process. That is what most technology is when you strip off the branding, a way of forcing matter to behave inside a box. And since we are talking about boxes that force matter to behave, you can drift into the quiet comfort of the home itself. Your home is full of little controlled environments. The refrigerator is a cold box that slows microbes. The pantry is a dry box that slows mold. The hot water tank is a warm box that fights a bacterium called Legionella, which likes lukewarm water too much. Too cold, and it does not grow well. Too hot, and it dies. So the tank is set to a temperature that is not about your comfort alone. It is also about microbial politics. Even the walls are a control system. Insulation slows heat flow, and vapor barriers manage moisture. Because water vapor is sneaky, it migrates through materials, condenses in cold spots. Mold is not traumatic at first. It is a smell, a stain, a cough that appears in winter and disappears in summer. And then, if ignored, it becomes a renovation budget. So building science became another branch of boring measurement. Humidity sensors, ventilation standards, rules about where warm air can go and where it cannot. The goal is not perfection. The goal is to keep your indoor world within the narrow band where humans thrive and fungi sulk. And you can see the theme now. Every comfort is a balance between competing systems. Warmth versus dehydration. Insulation versus stale air. Hot showers versus scald risk. Closed windows versus humidity. You do not solve these conflicts once. You manage them continually, mostly without thinking. That is what it means to live in an engineered habitat. It is not nature. It is negotiated nature. Now, if you zoom out one step further, you can see how measurement changed culture itself. Before reliable thermometers, fever was judged by touch. A palm on the forehead, a worried face, a guess. People did their best, but best is not the same as consistent. With a thermometer, fever becomes a number, and numbers travel well. A doctor can write it down. A nurse can read it later. A researcher can compare thousands of cases, and suddenly, illness becomes data, not just story. That is not cold-hearted. It is compassionate at scale. Because patterns hide inside big piles of numbers, you can discover that certain fevers predict certain outcomes. You can learn when to intervene and when to wait. You can design clinical trials, which are basically structured skepticism. And skepticism, used properly, saves lives. It prevents you from treating hope as evidence. This is another quiet gift of boring instruments. They reduce the influence of charisma. A confident person can say anything. A thermometer just sits there silently disagreeing. So you can thank the humble temperature measurement for pushing medicine away from pure intuition. Not completely, because humans never fully give up intuition, but enough that outcomes improved. Enough that you, in bed, are less likely to die of a treatable infection. And again, this progress was not a parade. It was a slow accumulation of better records, better standards, better habits. The kind of progress that feels invisible because it did not happen all at once, which is honestly how you want safety to arrive. Quietly. Now the cynical traveler in me has to point out the other side. Measurement also becomes a way to judge. Numbers can be used as weapons if you let them. A worker measured by quotas. A child measured by test scores. A sleeper measured by a watch that assigns grades to rest. It is very easy to turn a tool of understanding into a tool of pressure. That is the human hazard, the one you cannot ventilate away. So the comfort of knowing enough includes knowing when to stop measuring, knowing when a number has served its purpose and can be put down. A thermometer is useful when you are sick. It is not useful when it turns your day into a constant check. A thermostat is useful when it keeps pipes from freezing. It is not useful when it becomes an obsession you argue with hourly. Science does not require anxiety. Anxiety is just what happens when you mistake monitoring for control. And because you are awake enough to hear this, you are awake enough to handle it. You can let the sensors do their job without making them your religion. That is the soft landing. Now let your attention wander back to materials again, because materials are endlessly petty. Take glass, for instance, the hero of the old workshop. Glass looks like a solid, and it behaves like one in daily life. But it is not a crystal with a neat repeating structure. It is amorphous, which means disordered. In human terms, glass is a liquid that got interrupted. The atoms cooled too fast to arrange into a tidy lattice, so they froze in a messy configuration. That is why glass can have internal stresses. That is why it can shatter dramatically when scratched or heated unevenly. The thermometer maker knows this intimately. A tiny flaw in the tube, a scratch you barely see, can become a crack when heated. And then the sealed system fails, and the mercury gets a new home, your floorboards. So even the container was always a gamble, just a well-practiced one. Modern sensors avoid that particular gamble, but they have their own. Electronics drift with time. Solder joints fatigue with thermal cycling. Plastic housings age and become brittle. Batteries swell. Water finds its way into everything because water is the universe's favorite trespasser. So the modern world replaces one kind of fragility with another. Less toxic usually, more complex, definitely. And complexity creates its own need for maintenance. A glass thermometer could last decades in a drawer. A digital thermometer can die quietly because a battery gave up. Congratulations, your superior technology was defeated by a coin-sized chemical sandwich. But even that is part of the bargain. The cost of safer measurement is a dependence on systems that need periodic care. New batteries, quality control, proper disposal, because electronics become waste, and waste becomes chemistry again. Every solution pushes the problem somewhere else, preferably somewhere less likely to poison the person holding the tool. That is the goal anyway. And it brings you back to the theme that is, strangely, the most comforting. Your comfort is not a natural state. It is an achievement maintained by routines. Someone checks the power grid. Someone checks the water treatment plant. Someone checks the calibration of medical devices. Someone wrote the procedure for cleaning up mercury, and someone trained others to follow it. It is an enormous, distributed workshop, humming along outside your bedroom. So you can afford to be small for a while. You can afford to be unconscious. Now, speaking of small, let us go down to the scale where heat and measurement begin. Inside any object, temperature is really about the distribution of energy among particles. Not every molecule has the same energy at a given temperature. Some are moving faster, some slower. Temperature is an average, and averages hide drama. In your warm mug of tea, some molecules are energetic enough to escape into air. That is evaporation. The fastest ones leave first, which cools the remaining liquid slightly. This is why blowing on hot tea works. You remove the humid boundary layer, making it easier for energetic molecules to escape. It is also why sweating cools you. It is the same physics applied to skin. Evaporation is your body letting the hottest molecules leave, sacrificing water to lower average energy. That is a very calm way to survive. And if you ever needed proof that temperature is not a substance, just look at mixing. If you pour hot water into cold water, you do not get hot and cold. Coexisting politely, you get warm. Energy spreads, collisions share it out, and the system moves toward equilibrium. Equilibrium again, that point where arguments end. So, your whole nightly comfort is basically you and your bed negotiating toward equilibrium. You warm the sheets warm the air under the blanket, the air warms the pillow. Eventually the gradients shrink, and your skin stops complaining. That is why the first minute can feel chilly, and the 10th minute feels fine. Nothing magical happened. You just won the early negotiation. Now, to keep things grounded, consider the one place where humans still casually flirt with old-fashioned danger. Do-it-yourself repairs. Old thermostats sometimes contained mercury tilt switches. These are small glass bulbs with a bead of mercury that rolls to complete a circuit. It is clever and simple. It is also, in hindsight, like using a cobra as a light switch. Many have been replaced, but some still exist in older homes. If one breaks, you have a mercury spill again, just smaller. Fluorescent bulbs, especially older ones, can also contain small amounts of mercury vapor. Not enough to panic about, but enough to handle with care. So the modern world is not mercury-free, it is mercury-managed. And managed means you do not treat broken glass like ordinary trash. You ventilate, you collect carefully, you dispose properly. Not because you are fragile, because your nervous system is precious, whether you admit it or not. And that returns you to the soft idea of knowing enough. You do not need to memorize every exposure limit. You do not need to become an amateur toxicologist at midnight. You only need to recognize the category. Shiny liquid metal, old devices, broken bulbs, contaminated fish advisories. These are the places where mercury still hides in modern life. And once you can name them, they lose some of their power to surprise you. Surprise is what makes danger feel like a horror story. Method makes it feel like a chore, a dull chore, which is exactly what you want. Now the story can drift toward the boring future of sensing because it never stops. Sensors now live in networks. A weather station does not just record temperature for fun. It sends data to models, and models predict heat waves, cold snaps, storm tracks. A heat wave is not just discomfort, it is infrastructure stress. Power lines sag, transformers heat up, asphalt softens. Hospitals see more heat illness, so temperature measurement becomes civic planning, not just personal comfort. Cities map heat islands, areas where concrete and low vegetation trap heat. They plant trees, change roofing materials, design cooling centers, not because cities became sentimental, because heat kills quietly, and statistics eventually become persuasive. And in cold regions, sensors watch for freezing conditions that threaten roads and pipes. A small drop in temperature can mean a burst water main, and then